Hello, and welcome to the second lecture in the OxRAM Robot Arm software lecture series. Today, we're going to start playing around with ROS. So, in today's lecture, we're going to be covering how ROS works, including some key terminology and an analogy to aid your understanding. Then we're going to go through how to install ROS. Then we're going to look at ROS core, an important part of how ROS works. And we're going to run a simple ROS program to show all of the concepts in action. Then we're going to create a workspace to hold our custom packages. And finally, we're going to create a package that we're going to be using to contain all of our programs and code that we make in subsequent lectures. So a reminder to have the lecture slides and example code on hand, though I guess we won't be using the example code today, so just the lecture slides. At the GitHub repository. Now onto the lecture. So a typical ROS network is made up of lots of individual programs that work together to achieve some desired function. For example, getting a robot arm to move, or getting a robot to walk around a room and interact with things. So to do this, these programs need to be able to communicate with each other effectively and also send all sorts of data between each other. So this behavior is characterized by some key terminology. Now, each program is run as a node in the ROS network, and these nodes communicate by sending messages to each other. Now, messages are simple data structures that contain typed fields, so int32, for example, or a float 32, or a string, or an array. You can even get more complicated ones. For example, you can get a message for a pose, and a pose represents the position and orientation of something. Now, messages are communicated across topics, and topics act like communication lines, or I like to think of them as data buses between nodes. And publisher nodes send out messages onto a topic. Meanwhile, subscriber nodes listen to messages on a topic. Now, to help illustrate these concepts, we're going to go through a quick analogy. Now, imagine a sushi conveyor belt in one of those sushi bars. And now sushi chefs put out new plates of sushi onto the conveyor belts, while customers sitting at the conveyor belt can take sushi from it. Now, in this analogy, the chefs and the customers are both nodes. While chefs act as the publishers, they're putting the sushi onto the conveyor belt. The customers are the subscribers, they're taking sushi, or they are receiving the sushi from the conveyor belt. The conveyor belts themselves are the topics, and the sushi is the particular message that the chefs are publishing, and the customers are receiving by being subscribers. Now, a node can be both a publisher and or a subscriber to multiple topics, and you can easily set up new topics as well. So, a chef can also be a customer, and vice versa to multiple different conveyor belts. And also, when somebody puts sushi onto the conveyor belt, everybody receives that piece of sushi. So this is a one-way, many-to-many communication network. When any publisher publishes a message to a topic, all subscribers to that topic receive this message. So all customers at the same conveyor belt get a piece of sushi from the new plate that the chef puts onto the conveyor belt. Now, nodes can also interact with each other in more direct ways using ROS actions and services, which are a little bit more complicated, and we'll go over them in later lectures because they're really important. But they are still built from this publisher-subscriber framework that we've been talking about. Now, here I've illustrated a little diagram to convey these ideas. So you can see we have these two publisher nodes. We've got a topic, and we've got two subscriber nodes. So these publisher nodes are obviously publishers to the topic, and the subscribers are subscribers to the topic. And publisher node A publishes message A onto this topic. This message is then received by both subscribers. Then publisher node B publishes message B onto the topic. And again, both subscribers receive message B. So this represents this many-to-many one-way system. Okay, so here we are on the Ubuntu install of ROS Noetic page. So I recommend you. I've linked it in the lecture slides. I recommend going to this page now, and we're just going to go through the instructions for installing ROS. It should hopefully be quite straightforward. So the first thing that we need to do is we need to make sure that we're able to actually retrieve the packages that we need from the internet. So what you're going to want to do is you're going to go into software and updates. It's one of the, you can find it in the applications section. So if you go here and you go Ubuntu software and you make sure that you have, as it says here, restricted, universe and multiverse all ticked. So it's that we can download from all these sources on the internet. So make sure you do that first. So now what we're going to do is we're going to set up our sources.list. So we're just gonna copy paste this because it's quite long. So yeah, we're setting up our computer to accept software from the ROS packages server. So let's go there. So put in my password. There we go. Now we need to set up our keys. So what we first need to do is we go sudo apt install curl. There you go. It's almost done. There we go. So curl is installed. And then we're going to use this curl to add the key that we need in order to be able to do this, to install ROS. See, it says OK there. That's what we want to see. Okay, so now what we're going to do is we're going to do what we did again. We're going to update our package index, so where we get our updates and stuff from. So sudo apt update. This will, there we go. That seems nice and happy. Okay, so now this is where we're actually gonna, this is the install ROS of the install ROS tutorial. So sudo apt install ROS Noetic desktop full. You want the desktop full option here. So desktop full install, because that will provide us with all of the utilities and tools and stuff that we are going to want to use, and what you're going to want to use for the stuff that you make. So sudo apt install ROS Noetic desktop full. Okay, yes, I want to continue. This may take a while. So what I'm going to do now is I'm going to get back to you when this is finished. Okay, so it is finished installing. Okay, so now you can see everything's all set up. Now what we want to do is this environment setup. So when you use ROS, when you do ROS based commands in a terminal, you need to have made sure you've sourced ROS before you can actually execute those commands. And so this is what this next bit is going to be about. So every time you want to run a ROS command, you would need to basically run source opt not ROS noetic setup.bash, and then you can start doing ROS stuff in a given terminal. Obviously, that's a little bit annoying, and you'll forget. So what we can instead do is we can have this command line be executed automatically when the terminal is set up. So that's what we're going to do here. Copy. We're going to do echo source opt ROS noetic setup.bash, and we're going to write this onto the bash.rc file. And then we're going to source the bash.rc files. And the bash.rc file is what that's what the terminal uses to sort of set itself up when you load up a terminal. So what we can actually do here is we can go nano. So the bash.rc file is a hidden file, but we can go bash.rc because it is in the home directory. Here we go. Here it is. If we scroll all the way down, look at this. Source opt-ROS pneumatic setup.bash. So this line at the bottom here was added by us just now. And that will run every single time we load a new terminal. So we now, it's automatically set up, which is great. Exit. Yeah, we didn't make any changes to it. Great. So that's 1.5 done. Now, finally, this is to help for the future. We're going to want to set up ROS step. So ROS step is when we go on to having a workspace and making packages and stuff, all of which will be explained later. ROS step is a very useful tool that figures out automatically what you're missing. Like if any software that you're using requires of other software to work, ROS step will figure out what that is and it will install it for you. So let's sort that out first now. So let's go copy here. And then we're going to go that. Let's download the stuff. Yes, I want to download it. Getting there. It's almost there. And then we just need to run a couple more commands. Okay, it's almost there. Okay, yeah, that all looks good. So now we've just got a couple lines that we need to run. I'm just going to type them. Sudo ROS step init. Oop. Okay, see now it's telling us, it tells us to run ROS step update, but it also says in the instructions for us to do this. Step update. There you go. See, I'm always, as every time I run a line, I'm always checking to see that it's doing what it's supposed to be doing. Because if you make a typo and you don't look, you don't make sure it's doing specifically what it is, then, not good. Okay, so that all looks good now. So ROS step should be set up. Updated cache in ROS step sources.cache. So that's all. That should all be set up now. So I'm just going to close this tab, get a nice new one. And I'm now going to test our ROS installation. And I'm going to do that by running ROS call. There we go. And this is proof that we now have ROS working on our machine. So this is ROS core. So what ROS core is it's a collection of core nodes and programs that form the foundations of a ROS-based system. So this is like the underlying thing that's allowing everything else to communicate it with each other. Yeah. So ROS call must be running in order for your ROS nodes to communicate. It's providing this underlying framework. Yeah, it's the underlying web that connects all these nodes together. So that's what ROS core is. So great. Now what we're going to do is we're going to run our first ROS program. Very cool. So let's see here. We're going to want to use... Okay. You know what? I'm going to... What I think would be a good idea at this point is actually to show you guys how to install Terminator. I don't think I go through this in the lecture slides, but I'm going to just do this now because it will... I think it will help. So could you Control C to kill a ROS program, by the way? So Control C in terminal, that kills the program. So what we're going to want to do is sudo apt install Terminator. Yes, I want to install Terminator. So what Terminator is this is going to allow us to have multiple terminal tabs open at the same time, so we can see the feeds from each of them simultaneously. Because otherwise, you'd have to open multiple tabs like this, and you'd have to flick through them, or you'd have to have multiple windows, which is not great. So now that we've got Terminator installed, it should appear. There it is. There you see, and we're going to drag that there. Yep, that's all good. And then we're going to click Terminator. It's probably, yeah, it's quite small text here. So what we're going to do is, again, so I'm showing you how to make the font is how make the font larger. Here we go. So we're going profiles. So I think this is monospace regular size 16. There you go. That looks bigger. That looks much better. Okay. So now what you do, if you want to make multiple terminals, you can split them like this. So right click and then split horizontally and vertically. I'll just make 4 like that. Make that bigger. There you go. This is going to be very useful for you because often you're going to have many ROS nodes running at the same time. So again, so what we're going to do now is we're going to set up ROS again. So we're going to run ROS core. And note how we don't have to source ROS. It automatically gets sourced by that thing we did earlier with the bash RC file. So we've got ROS core running there. And then what we're going to do is we're going to go and we're going to run ROS run turtle sim underscore node. Hopefully this works. There we go. And look, we've got a little turtle. And then we're going to run another program. ROS run turtle. I think it's turtle sim. Yeah, turtle teleop key. Turtle sim teleop key. Aha, of course, it's turtle. See, you read the output. You can see that there's an error here. It couldn't figure out what I was trying to run. Now it knows what it's doing. So it's a good example. I want this to be visible, so I'm gonna close that, make that smaller. Okay. So while you have this selected, just play around with it. So I'm gonna use my arrow keys and I'm gonna just draw around with the turtle. There you go. Just like that. It's like playing a game, kind of. You can go backwards as well if you want. There you go. Yeah. So what we've just done is we've set up 2 nodes. So the first one we set up turtle sim node here. And what it's done is it's generated a turtle sim environment, which is acting as both a subscriber and a publisher. So it listens to incoming velocity messages for the turtle coming from the turtle teleop key, and it then sends out messages about the turtle's pose. So a pose is position plus orientation. So in this case, position is X and Y, orientation is theta. So the total pose is the X, Y, theta. So you can actually see here, X, Y, theta. Meanwhile, teleop key is acting as a publisher. So it's sending out velocity messages for the turtle according to the inputs in the keyboard. So what we're going to do actually is we're going to make this a little bit more, we're going to present this ROS topic list. So ROS topic list lists all the active topics. So you can see there's a couple. So ROS out and ROS out underscore ag are just, they're like ROS core related ones. You shouldn't touch them. But you can see here that there's topics have been set up for the turtle sim. So we've got turtle underscore command vel. So this is going to be the command velocity. There's going to be the pose, and there's also a color sensor one, but we're not going to look at that one. So if we go turtle, we're going to read these topics. So you can not only look up what the topics are, but you can also read the data stream through terminal as well. So we're going to say ROS topic echo / oh, and by the way, if you press tab while you're busy writing a command, it will fill out like the rest of the command. So if I do cm, it's going to, because command vel is the only option here which starts with cm, the terminal will automatically figure out that we're talking about command val. So now it's waiting. So now we're going to do arrows, and here you go. Do you see? Every time I press with one of the keys, it's showing the velocity command. So this is actually quite a decently complex structure. There's an XYZ for linear velocity and an XYZ for angular velocity, but obviously only the XY gets used for linear. Actually, no. Only the X gets used because you can't even go side to side using the arrow keys. But yeah, so that's a look into command val. So we're going to Control C to make that go away, and then what options do we have? What was that other one's name? Pose, just pose. Okay, pose. Here we go, and this is going to be a constant stream. There's going to be a certain frequency at which these messages are published, and you can see how the coordinates of the velocity, the linear and angular velocity of the turtle is changing as I move it around. So there you go. Yeah, so obviously the command velocity topic is used to exchange velocity command messages. So this node would publish those messages onto the command velocity topic, and then this would subscribe to those messages. Meanwhile, these pose messages, that would be published by the ROS-run TurtleSim node. So these messages that we were just seeing is actually coming from this one, while the messages we were seeing before is coming from this one, which this one is listening to, because this is a publisher and this is a subscriber to the topic of that other publisher, but it's also a publisher of the pose topic. Yeah, okay, so now let's just clean this up a little bit. So we can, if we press Q to quit here. Oh, okay, that's how you quit that one. But for example, this one, you have to do Control C. Yeah, and it's always good practice to exit your programs neatly before you close terminal. So I wouldn't, because what could happen sometimes, especially in more complicated programs, is the program can still be running in the background, and then it can be like a real pain to switch off. You'd sometimes have to just restart your computer in order to properly kill it. So make sure you do it cleanly by always killing the program before you exit terminal. Yeah, so I will get back to you in a second. Okay, so I've loaded up a new terminal, and now we're going to introduce the concept of the workspace and packages for a ROS system. So, programs and software in ROS are neatly organized and bundled together into directories called packages. Now, a workspace, or a catkin workspace, is a folder where you can modify, build, and install all of these packages. So a workspace is kind of like a build environment where you can build all these pieces of software called packages, and then you can build all of them together to make one big cohesive system. So when you want to use some ROS software, you first have to install the package for it into your workspace. So what we're going to first do, we first need to install catkin. So what we're going to do is we're going to go sudo apt install, this may take a little while, ROS, the ROS noetic catkin. Okay, so that's catkin. And then Python 3 catkin tools, Python 3 OSRF PyCommon. 3 catkin tools for Python 3. Yeah, that looks right, and I'll throw up an error if none of those packages exist. So by the way, the format that this works is we've got sudo apt install, so we're going to want to install some stuff. And then we've listed 3 things that we want to install. So ROS noetic catkin, so catkin for the ROS noetic, Python 3 catkin tools, and Python 3 OSRF PyCommon. So you sort of say package that you want to install. So sudo apt install, like that. I'm going to have to, using super user do, so I need to give permission in my password to install these quickly. It really shouldn't take very long. Very good. Yeah, and it's looks like it's found. Yep. Okay. Yeah, it did find both of them. Excellent. So now we're also going to install something called WS tool. So sorry, sudo apt install. I think. Check. Yeah, sudo apt install Python 3 WS tool. Yeah. WS tool. Yeah, like that. Oh, okay, it's already the latest version. Great. By the way, all of these things that I'm putting in terminal, all these lines, it's all in the lecture slides. So now what we're going to do is, should I put this in documents? No, I won't put. I'll keep this in home. Yeah, it doesn't make sense to put it in documents. Okay, so now what we're going to do is we're going to make the folder that is going to sort of contain our whole workspace. So we're going to do mkdir e tilde / tutorial underscore workspace / src. Okay, so we can see here is in our home folder, we've got this new file, tutorial underscore workspace. And inside there, we've got a source folder. Now, the thing with workspaces, you can actually name them whatever you want to name them. I'm cool, for the sake of this whole lecture series, I'm going to call mine tutorial workspace. But what I recommend you do after you finish this is to actually create a different new workspace, which is going to be the workspace that you're actually going to be doing your development on. And I'll briefly discuss switching between workspaces in a bit. But yeah, so now, no, we've made the folders here, but we haven't actually done anything really yet. So we haven't actually created the workspace itself. So we're first going to have to move into this source folder. So now we're now here. Well, we're actually there. Now we're going to add some dependencies. So we're going to use ROS step here. Yep, ROS step install y from paths dot ignore src ROS distro noetic. All required ROS steps installed successfully. See, that's what we check. And now we're going to actually go back. So I'm just going to go out like that, and now we're back into the workspace folder. So we're here, and we should have already sourced ROS, so that should be fine. So now what we're going to do is we're going to run catkin. So we're going to use catkin. Oh, you know what? We're going to need to quickly resource actually. So because we're going to be using some stuff that we've just installed. So source / opt. Sometimes you need to just, if you've installed something, it may not have been sourced yet as you installed it. Source / opt ROS noetic setup bash. Yeah. So sometimes you need to resource something, or you just close the terminal that you're on and open a new terminal. So sometimes if it says it can't find something and you're sure there's no typos or anything, that it's actually there, just resource ROS, or close the terminal and just open up a new terminal. So now what we're going to do is we're going to configure, get the folder ready for being turned into a workspace. So catkin config extend / opt / ROS / noetic. Catkin file. There we go. Look at that. Okay. So it sees that we've got source, but we're missing some of the other stuff because we haven't actually built the workspace. So now this is where the magic happens. We're on catkin build. And wow, look at that. There you go. We have our first workspace. So what we're going to do here is we're going to now we have to source ROS, so we should sort of set that up before, but you also have to source the specific workspace that you're working in when you want to run commands pertaining to that workspace. So if you want to run a node that's specific to a workspace, you have to make sure that workspace is sourced. So what we're going to do is we're going to go source slash tutorial underscore workspace slash devil slash setup dot bash. What we're actually going to do is we're going to say echo. So we're going to write this straight to our bash RC file. Tilt slash dot bash RC. Echo source tutorial workspace devil setup dot bash. There you go. So now if we, well, I'm just going to close this. Open a new one. So I recommend doing that now, or you'd have to source, run the sourcing as well as to write it to bash RC. So nano.bashrc. Scroll to the bottom here, and look, we're now sourcing this as well. So that's exactly what we want. Source tutorial underscore workspace slash devil so set up the bash. Wonderful. Yeah, and so when you're working with multiple workspaces, what you're going to want to do is you're going to want to go into bash.bashrc like I have, and manually change this line to say like source slash working workspace or whatever you call your workspace. So see how I've changed it here. So I'd save it, and then it would source that workspace instead of the other one. So you can have multiple workspaces like saved in your system, but only one of them can be sourced at a given time. So make sure that you've got the one that you want to source being sourced in the bash RC. So, but for now, we're going to be using tutorial workspace. So exit. We shouldn't have actually changed anything. No, I don't want to save it. So, but if I do enable bash RC, it should all be the same. Yeah, source tutorial workspace. I like to be very sure that I've done it correctly, because if one typo and you can cause all sorts of problems. So yeah, the workspace here. So we've got a workspace. So this workspace, it's made up of 4 main directories. So the source space, so SRC, it contains the source code for all of your installed and custom packages. So when we make new packages, we're going to put them in here. The other 3, they're very important for how the workspace functions, but we're not going to touch them. They're not covered here. Well, these are important for these are internally important, but this is the one that you're really going to be putting stuff into. So I have been talking about building workspaces. So what is building a workspace? Building is the process of compiling source code into stuff like executable programs. And in our case, each ROS package needs to be built before we can use the stuff they provide. Because it's one thing making some source code, but you actually need to build that into an executable object most of the time as well. So when we run catkin build, this command automatically builds all the packages in the workspace while also handling the interactions and all the dependencies between the packages when we build. So really, really useful, automates this whole process. Speaking of packages, let's build one now. So we're going to create our own package. So let's go to Terminator and then cd tutorial underscore workspace /src. So now we're in here, and we're going to create a package. So what we're going to do is we're going to say catkin create package, and we're going to call our package tutorial scripts. So catkin create package, tutorial scripts, and then we're going to say std underscore messages and ROS pi. Successfully created the files. Here we go. Oh, well, I think I've done this wrong actually. Yes, I must have. So delete. Okay, we haven't built it yet. You see, I've made a typo here. There you go. Yeah, I didn't have the space there. There we go. Tutorial scripts. Tutorial scripts. Very good. So, okay, let's talk about what we just did. So the first argument here is catkin create package. So that's, this is the command catkin create package. And then this is going to be the name of the package. So tutorial scripts is the name. And then we say what dependencies we want our package to have. So we want to have access to standard messages. So the standard set of message types like string and int and that kind of stuff. And we also want ROS pi because we want to be able to code in Python and create ROS code that works with ROS in Python. So ROS pi is the other package that we really need. So now we're going to have to rebuild the workspace. So we're going to go cd and we're going to back out tutorial workspace and we're going to run catkin build again. There we go. And you see now tutorial scripts is a recognized package. And in fact, what you can do, and here you see how it says workspace packages have changed. Please resource setup files. That's the thing that I was talking about. So the easiest way to probably do that is just open and close the terminal. And then if we do rospack list, this is going to list all the packages that's available to us. And what we're going to do here is we're going to look for the turtle sim one should be here, for example. Yeah, see, here's the turtle sim package. That's what the package that we used when we were playing around with the turtle sim. But notice, and most of these are all opt-ROS. So these are like core ROS packages, most of these. But notice tutorial scripts here. This is a recognized package, but note that its source directory is here, right there. So awesome. So now we've got our own custom package made that's ready to house all of our own programs and code that we're going to be working on for the remainder of this lecture series. By the way, every time you add a new package, because you're going to want to have multiple packages, each package does like a different thing. Every time you add a new package to your workspace, you're going to need to rebuild the workspace to incorporate that new package. Otherwise, it's just source code. You actually need to build that source code and integrate it with, and it needs to get integrated with the other code or the other objects built. So we went through how to create your own package, but there are already many, many different packages available online for you to install into your own workspace, providing all sorts of useful functionality that you might be wanting. And I really recommend looking up, if you want to desire some specific functionality for a system that you're making, try and find a package that does that on the internet. Maybe search the ROS wiki or just look it up on GitHub or something. Try and do that before you go about making something from scratch, because it can save you a lot of time. Trust me, I know from experience. I once spent 3 hours making a package that would allow me to control a robot through joystick inputs, but then as soon as I finished it, my supervisor pointed me to a widely used package that online that already does exactly that. So yeah, take it from me. Now, before you try to install a package, always make sure your Debian package index is up to date. So the classic sudo apt update. You can find a lot of available packages using apt search. So if you type apt search ROS Noetic, it will give a long list of things that you can install. But there may be other packages that you can't install through this method. Like you'll need to clone the package from GitHub into your manually into your workspace, and then you build your workspace. the apt search ROS noetic and then sudo apt install, that tends to install the package into your build of ROS, not your specific workspace. So yeah. Now to install the package, you do sudo apt install and then the name of the package. On a final note, the ROS wiki is an amazing resource for all things ROS. It gives plenty of documentation on the functionality of ROS and all of the different ROS related tools and we'll be learning about ROS services and ROS actions and so on and so forth in further lectures. ROS has excellent documentation on all of these things. The publisher subscriber system, ROS has excellent documentation on it. ROS also has information on many useful packages. So a lot of packages have their own entry in the ROS wiki explaining what they do. They give a technical explanation of how it works. They can give tutorials on how you might use it. They give installation instructions. So really useful stuff. And there's also lots of tutorials and example code to help you learn ROS. So yeah, the ROS wiki will probably be a resource that you'll be going to a lot in your development career, your software development career for robot stuff. Now, in summary, we've gone over how ROS works, so the core terminology, nodes, publishers, subscribers, topics, messages, all that stuff. We gave we illustrated how it all works with an analogy and a diagram. We went through the installation of ROS. Hopefully that's worked out for you. We looked at ROS core and thought about what it does, and we also ran the turtle sim program. So we set up a couple nodes and we saw how it all works together in the ROS network, looking at the topics and the publishing and the subscribing of messages, communication between nodes and how that works. We then made a workspace that's going to be our software development environment, really. So it's going to be where we're going to hold all of our custom packages of code, and then we set up our first package to hold our programs in code specifically for these tutorials. Now your homework will be to familiarize yourself with the ROS terminology. You really want these different terms to be second nature, really. And then you should finish setting up your workspace to make sure it all works. Maybe play around with the turtle sim again, and maybe there's other maybe there's other examples. Maybe if you find on the ROS wiki, maybe have a look at the ROS wiki and see if there's other examples demonstrating ROS, just to aid your learning. Now, next time we're going to start doing some coding in Python. We're going to be coding up our first ROS program. So that's the end of the second lecture. Thank you for watching. I hope you enjoyed it, and I'll see you in the next one. Goodbye.